Hey guys, welcome to my channel and I'm back again with another really interesting video. In this video guys, we are going to learn how we can train or fine tune open source Hugging Face models with our own data set and make those models customized for your own specific use case. So without wasting any time further, let's get started. So first thing first guys, if you want to actually fine tune your model with your own data, Hugging Face provides you two ways to do that. First is something which is a no code, no programming solution, and you can just do it with a UI. And that UI is provided you by the Hugging Face. We'll see that in a moment. But the second way is to actually write a Python program and just use the Python program APIs that are provided by the Hugging Face to actually fine tune your model with certain amount of data. Okay. So let's see both of these approaches one by one. Let's first start with the no code solution. So guys, in case of Hugging Face, the no code UI based solution is called as auto train. Now, if you want to fine tune your model with auto train, here is how you can do so. First of all guys, you can see that this is my Hugging Face account and you can see that one of the here you can see that 3 spaces have been created here and one of the space is called as auto train advanced. Now what are spaces? So first of all, spaces are basically like applications in your Hugging Face account. You can create multiple applications, you can actually train your models in your space. So there are multiple things that you can do in your Hugging Face spaces. And actually if you want to auto train your model, you actually have to create a space only. So let's first see how you can create that. So first of all, you go into your profile icon, you click on new space. Okay. Now in this new space, obviously you can give any name to your space. So let's say my space, whatever. And then select the space SDK. So for auto train guys, you have to select Docker. And Docker gives you multiple templates and one of the template is called as auto train. So there you go. Now you select auto train. Now the hardware or the CPU hardware where you want to actually train your models. Now you can see that this is a drop down and Hugging Face provides you multiple hardware configurations to train your model in. Now if you want to have a free one, you can just take a CPU basic which gives you 16 GB of memory. So obviously you cannot fine tune a very heavy model. You can maybe train a very small model if you want to. But otherwise you have to pay. Now the next thing is that you have to provide a Hugging Face token. How can I get a Hugging Face token? So basically guys, if you go to your Hugging Face account, so let's say I've got my Hugging Face account open and you go to your profile and you go to settings, you will see that there is something called as access tokens on the left hand side. Now these access tokens basically are login credentials to create spaces or to create things or applications in your Hugging Face account. And when you are fine tuning a model, then remember guys, you are not just reading a model. Okay, you're not just using it, you are actually fine tuning it and you are writing it back to the Hugging Face account. So you are uploading the new fine tuned model to the Hugging Face account. So you need both. You need read access and you need write access. So you just have to create a new token, give it any name, my token or whatever, and then you make the role as write and click on generate token. So once you click on generate token guys, then it will be generated here. As you can see, it has been generated for me. So you can just copy that token and go back to that particular page and you can paste that token here. Now once you paste that token, you can click on either making this model, this auto train model space as public, or you can make it as private. Public, if anyone of the internet, whoever visits your Hugging Face profile will be able to access that space or maybe auto train on the basis of that. But if you want to make it private, no one on the internet who visits your profile will be able to access that space. Okay. So for auto training, I would recommend keep it private because you don't want other people to, auto train your model again unless you want to do so. Then you can make it as public as well. Now if you click on create space guys, then your space will be created. Now because I have already created this space, I'm not going to click on create space. I'll just show you how it looks when you create your space and you land on your space page. So there you go guys. I named my model as my fine-tuned model, and when you click on create space, this is the page where you actually land on. Okay, so this is the page which gives you the auto train options for fine-tuning your model. So now let's jump into those options and let's understand them one by one. So first option is your username only guys. Obviously you need your username to make this model, train this model, and then upload it to your own profile. And then this is the project name. So obviously guys, if you want to name your model something, my first train model, whatever you want to name your model, you can just name your model anything, and you can just select on that, and that becomes your project name. Next is your hardware guys. So as I told you that Hugging Face provides you multiple hardwares to train, so you can select any one of these spaces, any one type of hardware if you want to, any number of cores if you want to. Just remember guys that only the CPU free one is free. If you select any other, it has to be chargeable, and for that you have to provide your billing information. Then becomes your text classification guys, then becomes your task guys. So what are you trying to do in this? So let's say I want to fine tune a text classification model, or I want to fine tune a image classification model like stability diffusion model or something like that, right? So if you want to filter on the models that you want to fine tune, then you can just select the task which is more appropriate for your nature. So let's say for my use case, I'm trying to understand the text, classify the text, or use text related things as my input, and then I need some output, right? So that becomes your text classification. So you can select text classification, and you will see that your base model will only now show you text classification based models. So you can fine tune on that. So basically, I can use BERT or I can use any model. Okay, just remember guys that if you select a huge model, like if I would have selected Mistral model or something like that, then it would not have worked with this hardware because the free CPU is only 16 GB. So just remember while selecting the model that your hardware must have enough space for that model. Okay. And now comes the most interesting part, that's the training data. So guys, what happens in training data is that you have to provide a CSV file or whatever Excel file that you have as a data, but that data has to be in a certain format. Okay, so you can see that you are given a column mapping here to explain your auto train that what type of format I have got in my data. Okay, now the column mapping basically is nothing but a JSON, and it has got two keys in it. So you can see the first text and the label. So text and label are basically two keys that you have to specify in your column mapping. And what they mean is that all the columns that are against to the text API are going to be the data, and all the columns that are against the label key, so this label, are going to be your target or the labels that you want to predict on, So let's say you have got a column called as let's say you have called a column called as sentence. That's your column, and what you want to predict on that sentence is the sentiment. Maybe you want to predict if the sentence is positive or if it is negative, right? So basically that's how you have to provide the column mapping, that the columns which are your data becomes your text key, and the columns which are the categories that you want to predict or the things that you want to predict becomes your label. Now you might ask this question, what if I have got multiple columns of data and multiple columns of labels to predict? Then you can just give it as a comma separated. So let's say I have got my sentence column on which I want to predict the sentiment, and then I have got the person column also. Okay, so let's say which sentence was spoken and who said that sentence, then that name of the person. Okay, person name, that becomes my second column, and both of them are my text data that I want to predict, that I want to use as a context to predict my answers. And then maybe you have got multiple labels you want to predict as well. So one label could be sentiment, that if the sentence was positive or negative, and another could be something called as a boolean value, where you say if it's a toxic sentence or not. So the toxicity could be a boolean value that you are predicting, that if the toxicity is present or not. Okay. So this is how you have to provide the column mapping. And once you upload your training data, guys, and you click on start training, it would start training. Okay. Now just remember, guys, that select a hardware which is free. If you don't select a free hardware, guys, then you have to provide your billing information. But other than that, guys, this tool is completely no code. You don't have to do any coding in it. And if you are a software developer or a data scientist who is a little bit more aware of how the parameters work, how the fine tuning works, you might also try to actually change these training parameters, play with them, and try to see if manipulating them makes a difference to your model and provide you some better results. Okay. But that's all you guys have to do, guys. It's just that you provide your data, click on start training, and there you go. After maybe 1 or 2 days, because obviously CPU free will take a long time to train, you will get your model created in your space and you will be able to use it just like you use any other LLM model. Okay. So that is something which is called as auto train. Okay. That's a no code solution for fine tuning. But let's say you are a programmer and you don't really want to use auto train, or let's say you don't want to pay Huggingface any amount of money with the hardware. You have a hardware of your own. Okay, let's say I have got a PC which is having a lot of GPUs on which I can train on. Then how you can do that? Now there is a way to do that as well, and that is through a script. So let's see that script. Okay. So for me, guys, I don't have a lot of GPUs or a lot of computational power. So I will only demonstrate that to you through the Google Colab notebook. Okay. Now this notebook, guys, don't you worry. This notebook is actually taken as a reference from Hugging Face only. So what I will do is I will provide a link to this notebook in the video description below. So you guys will be able to access this. Okay. Now let's see how the programming solution of training goes. The first thing first, guys, you have to actually install the transformers and the data sets. Okay. Now in case of Google Colab, because I was using a free version, I need pip install transformers torch. If you want, if you have a better machine, or if you are using on a local, you can just use pip install transformers and that will also work for you. Okay. But for me, because I was using Google Colab T4 tier, I needed a transformers torch version, or you would need a accelerate module to be installed as well. But don't you worry about it, guys. You will get that warning while you will be executing this code, so you will be able to understand what you have to do to install it. Okay. But for now, just remember that if the simple transformers API doesn't work for you, if you just install transformers torch, this same notebook will work. Okay. Now the next thing, once you have got the installation done, let's see how you can do that. So first of all, guys, you have to prepare a data set. Obviously, as I told you, that you need to fine tune on a certain data. Now for us, this is just an example. I have loaded the data set, which is a already existing data set in Hugging Face, and you can just load that data set by providing the name of the data set. So for us, it was Yelp review full data set. You can get that data set from Hugging Face and you can just call it the load data set. Okay. So once you do the load data set, guys, in the data set variable, you will get all the data set. Okay. But the load dataset function works in a very smart manner, where it will divide your data with training data and testing data. Okay, so if you just do dataset train and try to find out the 100 training data sentences, then you are able to do so. You can see that I have got this text, I have got this label. So the training data is provided to me as well. Not this is not 100 training data set, it's basically giving me the 100 characters. Okay, so once you have called the load data set, you have your training data and your testing data or validation data. Okay, now once we are done with the loading of the data set, okay, it is time to actually load our model. Okay, now so if you want to load your model, you can see guys that I am not loading the model first I am actually using a class called as auto tokenizer to create the tokenizer for that model. Now let's understand what is a tokenizer. Okay, so guys, basically our model is like a computer. Okay, now if you guys know computer doesn't understand human interaction. No, computer understands bits and bytes. It understands zeros and ones. Same thing, our LLM models, they don't understand actually your text. It seems like they are understanding it, but they don't. In actuality, they understand numbers. And what this tokenizer does is that it converts your text into numbers so that the LLM model can understand them. Okay. Now, every single model has its own tokenizer which converts the text or the input into a numerical format, and that format is now understandable to the model. So that's why guys, here we are actually choosing the BERT base cased model, and we are first loading the tokenizer of this BERT model so we can get started with our data. So auto tokenizer from pretrained will give us the corresponding tokenizer of this model. Okay, now we have written a function called as tokenize function, where we are basically using this tokenizer and we are taking all the examples, or I would say taking the input data, and then we are providing the tokenized result. Okay, now here you can see that we are also providing a parameter called as padding, and we are also providing truncation equals to true. Okay, now remember this thing guys, that you have a bunch of sentences, right? So let's say one of your sentences, he is a bad person, and one of your sentence says he is a really good person because he helped me in this and this and so on. So first text is so small, but the second text is so long, right? So sometimes to understand the text, what we do is, and also to speed up our process, what we do is that we truncate our sentences so that you know that only certain amount of text is enough. Let's say if I say that only if I only see 100 characters of the sentence, the first 100 characters, I will understand the context, I will understand the sentiment of the text. So that first 100 characters is enough for you to determine. Now in that situation, what you will do with the rest of the 100 characters, you can truncate it, right? So that is how you can speed up the process by using truncation methods. So in case of truncation methods, you set your length of the sentence at a particular, or the length of a text at a particular value, and then after that value you can truncate the rest of the remaining characters. Or what you can do is you can keep certain characters and then you only truncate only a bit portion of that. Okay, so that you have the context with you, so that you have got the gist of what you want to say, but you don't have the exact same the whole sentence that was given to you as an input. This is to speed up the process. The next thing, padding is also very important guys, because you can see here padding says maximum length. So as I told you that your model only understands numbers, right? And those numbers are actually in the format of a matrix. I would say it is in the format of a vector or a matrix, right? If you are familiar with matrices, you will know that matrices have a certain shape, right? So let's say your model is given a sentence which is of 100 characters, or let's say after converting that into tokens it has got 100 tokens, right? Now you want to actually take your model will be able to process those 100 tokens and it is able to give you the result. but we don't want our model to go sentence by sentence. We want our model to actually go batches by batches, right? You want your model to perform a little bit faster, so you actually are giving it multiple sentences in one go, so that it can it can fine tune on that and then go to the next batch and then go to the next batch, right? Now, when your model is training on a batch of sentences, it has to make sure that all the sentences, all the tokens are having the same shape. Okay? Because if it will see that, oh, some of them have a different shape, some of them have a different length, some of them have a different length, that won't help the model to actually train. It will create an issue, it will create an error, because some of the sentences are not in the same length as the others in the same batch. So what we do is, when we train our model or fine tune our model in batches of data, we make sure that all the data values or all the text values in that batch must have the same length. And how can you ensure all the text in a certain batch having the same length? Is by providing padding. So here we can see our padding strategy is maximum length. So let's say you are training or fine tuning your model in a batches of 5 sentences per batch. You are ensuring that all those 5 sentences in a batch will be having the same length by first taking the maximum length sentence in the batch. And what you do is, you can take the maximum length sentence in the batch, and then whatever characters are left in the other sentences, they all those sentences will be padded with some bits, okay, so that they all get the same length. Okay, so that is about tokenizing, guys, and that is about how you can do padding and how truncation can help in speeding up the process. So that's why these things are very important to understand. Finally, when you have got your tokenizer created, you have written your tokenized function, you can just do dataset.map tokenized function batched equals to true. Remember, by batching you actually make sure that your tokenizing is done very quickly. Now you have got your tokenized dataset. So if you have got your tokenized dataset and you try to display it, you will see, guys, that this is nothing but a bunch of numbers. It's like a matrix of numbers. Okay, but your model understands it, so that's what we want. Now you have your tokenized dataset, and you are just taking your training data and your testing data from that tokenizing dataset. And here you can see that I have taken my training data set, and I have only selected 1000 random sentences from it by shuffling it, and same for the test, taken 1000 test sentences from it and just shuffling it. Okay, now you have your small training data set and small testing data set. Okay, now what we have here, guys, is our data. So this was all part of the pre-processing. You have your data now. What we don't have is a fine-tuned model. That is what we are going to do now. So to fine-tune a model, guys, actually Huggingface gives you a trainer API. Okay, so, or I can say PyTorch actually gives you a trainer API, but Huggingface actually recommends using trainer API because it's very easy to use. Okay, so you can use this trainer class for optimizing the training process. Okay, and it is very easy. The first thing you do is you actually take your model and you load it. Okay, just like any LLM model, I have loaded the BERT base cased model. So you can see from transformers auto model for sequence classification, you are using the pre-trained model BERT base cased. Okay, now here you can see that when you load your model, it says some weights of this BERT sequence classification were not initialized. And basically what happens is that when you load your model through auto model, some of the layers or the top layers are actually not loaded. Some of the weights are not loaded. And why is that so? Because that is what we want to do, guys. We want to cut down some of the weights from our existing pre-trained model and basically add our data, fine tune our data and replace those layers. Okay, replace those layers with the new weights that are actually trained on your own fine tuned data. So this is completely normal, so don't get thrown off by this warning. And now it is time to actually create the training arguments for our model. Okay, so for training arguments you can just use the default training arguments. You can just use the training arguments class, training arguments, output directories, test trainer. So basically what's going to happen is here in your Huggingface, if you click on this directory, you will see that a directory will get created called as test trainer, and this test trainer directory will basically set the events of training the data, because the training of the model takes a long time to train. So it will keep on putting out the events or any of the logging in this directory. This becomes your training arguments. Okay, now you can obviously change some of the training arguments, guys, but just for making this demo a little bit easier, all the default training arguments are going to be there. Okay, and training arguments are nothing but hyperparameters, guys. They are just hyperparameters which you use to modify your model, fine tune it a little bit in a better way. So if you remember, I was showing you this in same thing in auto train as well, that you can change your training parameters. Okay, and here also you can. Okay, we are just using some default ones. Now we know trainer API is there, and trainer API will actually train your model. What it will not do is evaluate your model. What it's not going to do is actually measure or create the metrics to actually make sure that this model, or how better this model is performing against certain parameters. Okay, so for that we are importing a evaluate function, and that evaluate function will load a accuracy metric in the metrics variable. Okay, so let's say I want to evaluate my model, and I want to evaluate on the basis of accuracy, like how accurate it is. So this is just for evaluation of the model. Once you know that accuracy is the metric that I am going to evaluate my model on, you can just create a metrics function, like a compute metric function. This is basically nothing but a function which is actually using the metric that we created. So this metric was nothing but the accuracy metric that we just loaded, and then it is using this metric and computing, or basically I would say comparing the predictions and the actual labels. So it is just making sure that if we have predicted all the right labels, or if we have predicted some of them are right, or like how accurate your model is. So this compute metric function is just finding out how accurate your model is, or basically on the basis of the metric that you created, it is evaluate the performance of the model. So now guys, we have got all the things in place. We have got our training arguments. We know what is our evaluation strategy. We know what is our model. We know the tokenizer as well. So we have got everything in place. Okay. So here you can see that they have created a training arguments again. But this time, along with the output directory, we also provided an evaluation strategy as epoch. Okay. Now, what happens in evaluation strategy as epoch is that epoch is nothing but you're training your model in batches, right? You're not training one at a go, that once your model is entirely trained, then you will get to see what evaluation, how it is performing, right? You want to see that every single epoch, like every single step when your model is fine tuned, how is it performing? Let's say after first batch, it performs like this. Second batch performs like this. So we are just changing the evaluation strategy to epoch, so that we can report the evaluation metric at the end of each epoch. Okay, so at the end of each batch training, you will get to know, okay, now my model is training like this. Okay. So once you have got everything in place, you can just create the trainer class object. So trainer, pass your model, pass your training arguments. So we just changed our training arguments with the evaluation strategy. So I'm passing that. Then what is your training data set? So we only took like 1,000 random sentences for training. So that becomes my small training dataset. Evaluation dataset, which is my small testing dataset, for that we used 1,000 random sentences in the test dataset, that becomes the eval dataset. What is the metrics for evaluation? That is your compute metrics function, and that metric function is metric evaluation through accuracy metric. Okay, and finally guys, you just do trainer.train. Okay, once you do trainer.train, you can see that this is a epoch training, and it took around 3 hours. You can see it's 3 hours 19 minutes. It took around 3 hours to completely train, and it gave us there were 3 epochs it was ran on, and for every epoch you will see that this was the accuracy, this was the accuracy, and after the end of third epoch the accuracy was the best. Okay, and this is the final output, how much training loss, how much total loss, how many samples, etc, etc. So now guys, you have got your model completely fine tuned on your own data. Okay, but can you use this model through this notebook? Yes, you can. However, once you close this notebook, the model is gone, right? You are not able to use it again unless you rerun this entire notebook. So it is very, very important that you take this model and you save it somewhere. And what better place to save it than the open source Huggingface account? So for that guys, you just have to do your Huggingface login. So you just do Hugging Hub notebook login. When you click on when you call notebook logging, it is going to give you this token. Now in this token guys, you just paste the same right token that you created in your Huggingface account. So once you click on this and paste the same token, and you click on login, you will actually log in into your Huggingface account. And after that, once you are logged in, you just do trainer.push to hub. So your trainer module is already created and it has already trained your model. But by calling push to hub method on the trainer class object, it will actually push the trained model to the Huggingface repository. And once it's pushed to the Huggingface repository, you can access that model just like you have accessed any other model. Okay. So I can show you that on my profile. Okay, if I go to my profile, you can see that under the model section, so this was the Distilbert uncase fine-tuned squad model that I actually fine-tuned using the similar approach. Okay, so once you push your model, once you do push to hub, it will get created like this. And now basically you can click on the use in transformers button here, and you can see that it has given you all the code for actually using this model. So auto tokenizer from pre-trained, auto model for question answering, you have your model object, and then you just use this model to provide it an input just like through any LangChain API. Okay. Now how this exact model was created guys, this is actually a different type of model that I have pushed. This is a question answer basis model, and the notebook that I was just showing you is actually a simple text classification model. Okay, so it depends upon you guys how you want to train your model, which model you want to train, which type of data set you want. But we have got n number of options, and obviously this simple notebook you can just have many variations of that. Okay, so that was about how you can use auto train to train using no code solution and trainer API to have a coding based solution for fine tuning your data. Now before I leave you guys, I also want to show you that this type of examples you can find in Huggingface anywhere. So although I will be putting the link to that particular notebook in the description, if you just want to fine tune your pre-trained model and you are looking for some sample examples, you just Google fine tune Huggingface model, and the link that you get is fine tune the pre-trained model link. And this is basically the link that I used for showing you as a reference. However, the good thing here is something called as examples. So if you try to see examples here, you will see example notebooks. See our examples or notebooks. So in this example notebooks, you will see, sorry, it was not example, it was clicking on notebooks. So if you click on notebooks, guys, if you click on transformers notebooks, basically, you will see that a lot of notebooks are provided. So for example, you can train your own language model. You can fine tune on a token classification model. You can fine tune on question answering model, and like you have got all the examples to generate text, generate text with constraint, etc. You have got computer vision notebooks. So if you go into the transformers notebooks link, guys, you will actually get sample notebooks for fine tuning all different types of models. So not just the BERT uncaged model which we use, but you can also deal with something like computer vision or audio classification, fine tune that model as well with your own data set. Okay, so this is how, guys, you can use Hugging Face effectively to make your own customized app which are more suitable for your own needs. So I hope this video was informative for you guys. I hope you learned something from it, and I hope you are going to use these same approaches to fine tune your model and upload them to your Hugging Face space. I will be looking forward for that. Please do write down in the comment section below, guys, if you try out these approaches. It will be helpful for all. If you have not yet subscribed to my channel, guys, please do subscribe and hit the bell icon for future notifications of more such programming and coding related videos. And if you like this video, guys, then please do not forget to like this video and share this video with your friends. I'll see you guys in the next video, guys. Until then, take care and bye bye.